charging LEDs. Here is simple 1000 microfarad capacitor with 47 kilo ohm. 5 minutes later, at 6 minutes time, at 7 minutes, 3 LEDs are blinking. At 8 minutes, 3 LEDs stopped. At 11 minutes time, 15 minutes after start. Half an hour later, we have the winner, the board with Schottky diode. Now get a comparable performance. What I did is to use just single LED and put a Schottky diode which has low voltage drop. With 3 LEDs, Schottky diode voltage exceeds maximum back voltage and it doesn't work. Current measurement results: 18 microamps at 9 volts, 15 microamps at 9 volts, 150 microamps at 9 volts. It is 10 times more. And at 3 volts we have 1 microamp, and here we have 2 microamps at 3 volts. But here we have 12 microamps. Circuit I can test at higher voltage because capacitor is 35 volt. If I am at 20 volts, we get 80 microamps current. And if at 30 volts, and get 300 microamps. If the resistor is unsoldered, then without resistor gets 6 microamps at 30 volt, which is very impressive. Maximum power 6 microamps, 30 volts, it is 0.2 milliwatts. This then is governed by the resistance of the Schottky diode. Main circuit around this transformer, which should have very low loss. We have 3 LEDs in series. They make like a voltage regulator, and also transistor base 0.6 volts, and white LED is about 3 volts each. And if they do not shine very well, then there is feedback to capacitor. This is how I understand this diode, but also this diode has some internal leakage resistance. It's not perfect, so the circuit sometimes works without this 10 mega ohm resistor. And the interesting mode is when capacitor is put across. If capacity is very small, then it will blink for many hours, but very dim. In the construction we have a transformer with ferrite around, then there are very small radiation loss. Here is 10 mega ohm resistor, this is capacitor, and behind is hidden diode. Here is transistor, 1000 microfarads. This is with a large transformer, 5 centimeters diameter. Flipped LEDs. The oscillation without LEDs. LEDs are disconnected. This is with LEDs, direction like in schematics. Increasing voltage 6, 7, 8, 9, 10, 15, 17, 18, 25, 28 volts. And now here increasing voltage 3 volts, 4, 5, 6, 7, 10, 11, 12, 13, 15, 16, 18, 25, 28. Comparing big and small coils. This is big coil frequency, and this is small coil frequency. It is higher. Both are running down quite evenly. This is now circuit with very tiny transformer. At low voltage it is not enough voltage to drive all 3 LEDs, and I had to put a capacitor 22 picofarads between plus and diodes to get reliable oscillation. Oscilloscope trace looks quite different. There are no slow oscillations. Running 3 circuits from 9 volts. Surprise, single LED is the brightest. The big transformers become dim We seem to have a winner, but it's unfair competition. And round, just single LED. This one is slightly brighter. And still the winner is a small transformer. This run I disconnected the diode for this oscillator to see what is the difference. Without the diode, this one stopped first. Next run with a Schottky diode, and the brightest is this one in the middle. With the Schottky diode, runtime becomes longer. In a long-term race, now this and this have comparable duration. Well, with Schottky diode is the winner. The run Schottky, Schottky, regular diode. I had to discard several Schottkys. They did not work. They had bad resistance in backwards. One is still the loser. Then comes this one with the regular diode, and winner is this one with good Schottky. This selected good Schottky diodes, it takes forever to wait, almost half an hour.